Hi folks, we're going to take a look at the extra review package number 51. So here, let's recap the problem. There's a 500 kilogram scoreboard which is being held up by 4 cables, each making an angle of 70 degrees with the ceiling. And they tell us that the weight is evenly distributed on the scoreboard, and they want us to find the tension in each cable. Okay, so we've solved these types of problems before, but with only 3 vectors in play. The tension's in 2 strings plus the force due to gravity. But here, a little more complicated because we've got 4 strings, okay, holding it up, and of course the force due to gravity. So 5 vectors to deal with. And this isn't even a 2D problem. There's no way to draw this as a 2D problem with all these vectors. Okay, but because they tell me that the weight is evenly distributed, that means that, again, assuming that the ceiling is horizontal and the scoreboard is horizontal, the tension in each string will be the same, or each cable will be the same. So that's why I'm going to deal with only 1 cable here. So here's the corner of the scoreboard, and it's being held up by this cable, which is attached at 70 degrees to the ceiling. Okay, and there's a tension in this cable. Okay. But remember, we have our force due to gravity, so I'll just consider the magnitude here of the force due to gravity. And so what's keeping this from falling? Well, it's going to be the vertical components of the tension in the string. Okay, so this is what I'm going to try to find, is the vertical component of the tension. This will be the tension in the cable here. Okay, but because there's 4 of them, I have 4 times the tension, or vertical component of the tension in 1 cable is just going to be equal to the force due to gravity going in the opposite direction, which is just going to be 500 times 9.8, since we have the mass. And so the vertical component of the tension vector on one of these is just going to be given by 500 times 9.8 divided by 4 is 1225 newtons. Okay, so now what I'm going to do is I'm going to use the fact that this is perpendicular to the horizontal, so that means we have a right angle triangle. If this angle here is 70, this angle inside the triangle must be 20, and this is just the adjacent side, which we found was 1225, so I can just use cosine to find the magnitude of that vector there. Okay, so here we have cosine of 20 degrees is equal to the adjacent side, which is 1225, over the hypotenuse, which is just the tension in the cable. And so the tension in the cable is just given by 1225 divided by cosine of 20. Okay, which is about 1304 newtons. Okay, so there we have it. So what made this problem relatively easy to solve was to realize that we only had to deal with 1 cable at a time, and then to realize that it was the vertical component of the tension in the cable that was helping to hold up this scoreboard. So 4 times these vertical components gave you the same magnitude as the component, the magnitude of the force due to gravity. And then from there we were able to solve with some fairly straightforward trigonometry. Okay, that's it for this one.